recording, and we're underway. We are on chapter 11 this week, and I've got all of y'all's chapter 10, 9, and 10 from last week was all graded through yesterday. I didn't get 10 graded until yesterday, but in all of my classes, as of Friday, except for y'all's chapter 10, I had graded everything in all of the classes that was due last Monday or before. And I did get the chapter 10 done for y'all's yesterday, so that's up to date on that. And then I'll be working today on grading discussions and stuff. I am doing this session from home today because yesterday, both sessions I did, it was poor connections. And so I'm doing this one from here today instead, and it's showing me all green in my upload on it. Actually, in the download also, upload, they show a 392 kbps. Apparently that's their speed out there, because that's sure not my speed. And then download, they're showing a 32 kbps, which is rather odd. Usually your download is faster than your upload. My connection is a whole lot faster than that, so apparently Blackboard really slows things down. All right, so from there, I've got y'all all marked on attendance. I have not marked attendance for y'all's class last week yet. I'll try to get that done real quickly also, along with this week's. Just as a warning, if you do the discussion along with the live collaborate, sometimes that gives problems on the grading that I don't catch. If I do get the collaborate grades out there before I grade the discussion, it'll then use the discussion grade. Whatever is the last grade I enter, it uses as the grade, even though I've got it marked for highest, but that it sees in this case just as all one submission. And I have to go back and override, but I may not. I try to notice as I'm grading the discussions if there is already a grade showing for you, and if there is, if it's higher, I go ahead and give you that one. But I don't always notice that because there's a bunch of discussions I grade each week. So if you do have the point where you got the wrong grade showing, that you attended collaborate, but it's only showing, and you only did part of the discussion and it's showing only a partial grade, let me know. I'll double check it and then correct it on it. So that's that. Okay. Just mentioned to you, this weekend I'm not going to be on Saturday. I do not expect to do any checking email or anything on the internet. I'm going to South Carolina to learn how to judge barbecue. And that's an all-day thing for like 5 hours, and then there's a lengthy drive there and back, so that's going to fill up my whole day. So if you send me emails on Saturday, don't expect responses until sometime on Sunday, and it could be later on that. But I should be around the rest of this week at school, Wednesday, tomorrow, and Thursday, and Friday. I'm going to be out for a little bit. I've got an appointment that day. Okay, let's look at chapter. We've only got chapter 11 this week, and there's actually not much in it. So I think we're going to get through this session real quickly. So I'm going to, because I'm working from home, I don't have dual screen. I'm going to share my screen to make it easier for me to just follow. Well, that'll let y'all see on it what I'm doing. So I'm going to share the screen. And then y'all see on it. Let me find the tab for it. It sort of mixes them in a different approach. This one, yeah, that's it. All right, so then y'all see where I'm talking from. So in chapter, hopefully y'all can see it now. Let's see what we got here. Yeah, So I'm assuming y'all can see that. So again, I have to come off of it. Let me turn my speaker on. That way I'll hear beeps when that happens, because I have to work off of their screen on it. So half of the chapter is on network devices. The other half is on wireless devices. So the first one is, let's go real quickly through network devices. There's not a whole lot in here on it. They do take you through the process of how stuff is passed through on it. So the first thing to talk about is there's end devices, which are the devices we're all using. So when they talk about end devices, that's on that. And so they take you through a video of showing that one. And then they talk about your intermediate devices, and the router is going to be your big one on that. The router allows you to connect multiple networks together. It works on layer 3, and that's where routing occurs. So when you see the word router, you're looking at layer 3. And it connects your different networks together. Now, with what they've got illustrated there for the home office, and they're showing a router on that, you're going to discover that's actually technically right there a layer 2 switch. I mean, a layer 3 switch we'll discover in just a little bit. But they've got it as a router there. So they've did a complex one right here for you, with things hooking to the firewalls and to switches and so on. But the big thing is they're looking at is the routers at this point. But the routers are going to determine the path that things go on, and also they're going to forward our packets. So we're working with packets when we're working with routers. With switches, we were working with frames. So then they mention on that, they show you back in terms of the OSI layer right here, in terms of encapsulating and decapsulating, that something gets sent out. It came all the way down to 7 layers and got shipped out, and it was sent to the next router, to the router that PC connects, that this network connects to. When the router receives it, it is going to take it up to layer 3 and decapsulate it and determine where it's supposed to go, and then it will send it out on the re-encapsulate it back down to a frame, resend it out on the interface that is pointing towards where it wants to go. And it will keep on doing that through the routers until it ends up in a router that's connected to the network that PC2 is on. And then at that point, it actually will put on it the MAC address for the PC2. But the whole time along the way, it has kept holding on to, as far as the IP address of the destination. And then when the PC gets it, it runs it all the way up through all 7 layers. So then they take you through exercises to make sure you do read this. So as it gets it, when it pulls it apart, that it took off the frame part, and then it's got the packet there, which has got the IP address, the destination IP address, and source IP address. Those are going to stay the same the entire forward through the whole network. The MAC addresses change all the way through. So the router looks at that destination IP address and sees, does it know anything about it? If it does not know anything about it, and if there is no default gateway set up, it just trashes it and does nothing with it. If it does know what address to send it to next, then it will put that MAC address onto it, as it will pass that down and get the MAC address put on it by the switch, and that it will forward it out. If it doesn't know, but it does have a default gateway, it will send it to the default gateway and use that address on it. But the IP address still stays constant from where it came from originally. And so they show you different ways on that, that if there was no default gateway, it uses that. If there is a default gateway, that's where it's doing this long one down here. And if it knows the actual address that's on its network, it sends it specifically to that device. And it doesn't care whether it's an IP version 4 or IP version 6, it's going to work basically the same. The IP version 4 is going to look at the ARP table when it knows the IP version 4 address to get the ARP table to get the IP version 4 address and the MAC address. So it's going to look it up by the IP version 4 address and get the correct MAC address. And if it's not there, it's going to send out a request for IP version 6 is going to use the neighbor cache to do the same type thing. And does neighbor solicitations, but instead of using ARP to do it. So they mentioned that there's directly connected routes. Those are the ones that directly connect to the device. And then there's ones that are remote routes. And with a remote route, all it knows is which interface to use to get to that remote connection. That doesn't mean it knows all of the devices it's to pass through to there. It just knows what's the interface to send it out on and what's the next device it should go to. But it's not dealing with all the way to the very end. There's static routes and there's dynamic routes. Static routes are routes that we enter into the routing table and that stay there. Dynamic ones are the ones it learns and it passes those on along. EGIRP and OSPF are advanced things, methods where it does that. And they're the dynamic routing protocols. Because it's the route protocols we're really working with more on this right here. And those you'd learn if you took CIST 2452 and 2453, you'd learn about those in those classes. So some of you may have had those, some of you may still be going to take those courses. And they take you through a number of exercises showing you this whole process here, so that's good on that. And then they talk about hubs, bridges, and LAN switches real briefly. Hubs you should not be using anymore for networking purposes. You will use hubs and USB and some other type things, but hubs, when you have a hub, signal comes in, it goes out all ports. A switch is just like a hub basically, except it's intelligent, so it only sends information out on the port it belongs to if it knows which port that is. It only sends to everything when it doesn't know where it goes. That speeds up the traffic on it tremendously. Basically on a hub, if you've got 5 devices connected to it, you've only got 1/5 of the speed effectively of your network. On a switch, if you've got 5 devices connected to it, you've got essentially the full speed of your network to each of the devices. A bridge, you're not going to see much anymore. But they were out there, and that they connect one network segment to another network segment, whereas with switches you connect a number of them together. So bridges just connect a single network segment to another, but those, just like hubs, are really older things on it, but it only has 2 interfaces. But it will split your collision domains up. It was the nice part about bridges, but not very often. So now you're going into switches. The major thing on it is using MAC addresses on the switch. It knows about the MAC addresses for all devices that are connected to the switch. And so then when something comes in, if it knows that address, it sends it specifically on that port. If it doesn't know the address, then it will broadcast it out to all of the ports. But that cuts the amount of traffic on everything down tremendously. Then when anything on a port sends in, it learns the MAC address if it didn't already know it. So it dynamically adds it to its table. I heard some clicking in the background, so let me look and see. And I see a couple more people have joined in. And so let me get those. There, I knew there was another one. 3, 4, 5, 6, 7, 8. Yeah, I got all of y'all now again. So let me continue on. So that's the way the switch is going to work. But it's always going to examine the destination MAC address and determine where to send it to. And then any questions on the switches or the routers? I'll pause right there real quickly. Okay, I'm getting lots of no's. I'll listen if it beeps telling me somebody else put something in. So the last thing they mention in this half of the chapter is VLANs. And what a VLAN has a nice part about it is you've got your network set up in subnets. But a VLAN will allow you to set them up in a local area network combinations across your subnets. And so this illustration here is nicely showing on it. The switch sets it up for you. And so on the switch, you'd set up a VLAN, and then you'd say that these items all hooked together coming through that switch are all on the same VLAN. So they work like they're on the same subnet. But if you notice on their addressing that they are slightly different on that. Okay. So that each of the VLANs has its own separate subnet address. So the VLAN is going to give you the capability to create subnets within your network. You'll use VLANs across the internet also sometimes, and you can actually play them across there on it. So you can have stuff from, in this case, they show you in terms of floors of a building, going out on the internet, that it could actually be playing across into different countries or whatever. VLANs are really nice on that, and basically what it does is it makes it work just like that they're all local right there together. I've set up a VLAN a few years ago that was connecting two offices together, one in Millen, Georgia, and another office in Waynesboro, Georgia. And each of those had its own little network, and then they were connected together through the switch on it, which caused it to work like that. It looked like to those devices on both of them that they appeared like they were all right there local together. So it will work like you're locally there. So it's a virtual local area network. And those can be very useful to you as also a secure, makes your stuff more secure in a way. So then the last thing they mentioned right here in this half, that, well, it's not the last thing. Okay. STP is then mentioned, and it's just very barely mentioned. And it's just a way to prevent you from having redundant paths and stuff, having a problem because of these redundant paths. What it does is it says in its spanning tree protocol is that it's got a loop-free path between the devices set up in it, and it keeps from getting caught in a endless loop on it, never getting to the destination because things looped back around because you've got multiple connections all on it with redundancy. And that'll get rid of a problem of redundancy that you can end up getting stuff caught in a loop and it not getting to where it needs to go in the way it was going. But you really don't need to know much about STP at this point. In the Cisco classes, and I think it was Cisco 3 is where we cover STP for you. Multi-layer switching, just be aware of that one. Basically what it does is that it's where your switch works as your router also. And that goes back to what I was mentioning in the very first of the class, where they had drawn as a router, but they had a bunch of local devices connecting off of it, so it was a switch too. So multi-layer switching is where you have a switch that You'll also see it known as a layer 3 switch. Well, technically, switches aren't on layer 3. Routers are on layer 3. Switches are on layer 2. And remember that way normally. But with multi-layer switches, that's where the switch has the capability to do routing also. And so what it is a switch that has the ability to do routing. Back when we used a lot of bridges, that you would have bridges that would also do the same type approach, and they were that had the routing capabilities, and they were called routers. But switches, if they've got the routing capabilities, they're called layer 3 switches. And so watch on that one, out for that one. And then switch virtual interfaces is just one that allows you to hook to your various virtual, your VLANs. So it gets you even more association on it. So that's just a brief one on that. Wireless communications, not a whole lot in here too. Most of it you've already heard, know stuff on. So they go through and talk about the difference between wireless and wired. I think y'all pretty well know that already. Did I talk about collision avoidance and collision? I talked about collision avoidance and collision detection in here the other week, didn't I? Somebody tell me yes or no. Because with collision, then I get the two classes, my 2451 and this class mixed up. Okay, collision avoidance says, and that's using CSMA, which is carrier sense multiple access. Collision avoidance says before something's sent, it sends up a signal and says, I'm going to send something. Is anybody going to collide with me? So basically, it's like sending up a flare before you back out of your parking space to warn everybody you're going to back out of parking space. Don't come by you. Collision detection says we just look to see is there anything right then, and then we proceed to send. And then it may run into another frame on the network. And in that case, a collision occurs. And then we have runts floating around on it and stuff. Collision avoidance, you're not going to have collisions, but you're sending up, you're sending out frames that are going, we're getting ready to send, is it clear? Wireless uses collision avoidance. Wired Ethernet uses collision detection. And so, and now if you're using a switch like you should be, with each port only having one device on it, the way that's set up will prevent you from having collisions also. But if you got shared items on there, you still could have collisions occur on it. Your object in the Ethernet, the wired Ethernet with collision detection is not to get zero collisions usually, although you can get to that if you're using in a pure straight switched environment, but to keep them to a minimum. Because and it's just like out on the highways. We'd like to get to zero collisions on the highways, but that's very unlikely to do. So our main concern is reducing the number of collisions down. That cars are still going to run into cars, because even on the racetrack, and that's why a lot of people go to the races, is to watch collisions. But and where we mentioned, and I'm pretty sure I did mention token ring in here, but maybe I didn't. That one would be also a collision avoidance environment. But wireless actually checks to see can it send it before it sends it, which is always different to me. Signal interference, you have lots of on wireless, on wired. It depends how you got your wiring done. You don't have much. Flips down. I've got to go back to the correct screen or it won't scroll. So they talk about the frame structure right here for you again that they mention. The address. Why have they got 3 addresses? I've not seen 3 addresses in a frame before, but they've got 3 addresses here. That's an interesting new one to me. Speaking of which, I also did put in your class in general discussion, a handout on, and this fits right here, with wireless, that now you can do random MAC addresses, so that instead of your machine having a fixed MAC address it always uses, you can set random MAC addresses on Windows 10 and Windows 11. And that's not the original version of 10, but the updated versions of 10. What that does is, instead of connecting with the MAC address that's burned in your machine on your NIC card, it uses a random one. And what that means is somebody that's hacked in and picked up your MAC address, they don't have the right MAC address when they hack in using, if they picked it up from wireless, and so they can't get in using the MAC address to your machine. So it makes it a little bit more secure. CSMA CA I just mentioned to you. With CA, it looks to see if the channel is idle, and then it sends a signal to say it's ready to send a signal. If it receives a clear to send, it then proceeds to send. If it doesn't get that one, it waits and tries again. CSMACD is where it just looks and sees, is there anything going by right now? If there's not, it proceeds to start sending. Sometimes it glides, and then all of the devices are always listening for collisions, and that's determined by seeing runts going by. And what I was just telling you about just a second ago with the random MAC addresses or random hardware addresses, actually Windows calls it random hardware addresses, and read my article on it. That's actually the article I wrote for the newspapers for this week, for about 4 newspapers, and I do it as volunteer. Your wireless, your access point is advertising out, and your wireless device is always looking continuously for access points when it's not connected. So access points are sending out message signals saying that they're available with their SSID, and we can hide that one. And then your device, like your laptop, is broadcasting out when it's not connected to anything, is broadcasting out looking for an access point. And that's where the random addresses comes in handy. So they talk about active mode and passive mode. And so they show you in terms of passive, that's the access point, is sending out the signal to the wireless client. And then the other one is sending the other direction. So then wireless devices, it mentions real quickly a couple of things on that. The access point is where it's always making contact to. And then they throw you in here also the LWAP, that they mentioned that one to you. And so they throw you a new one for you on there. But notice they don't put those very large into the midst of their stuff. So the LWAP is a lightweight access point. And what that means is that it's not, it will forward them between them, and that they're not as strong of devices as they were before. And then the other one they had there was the WLC, which is your wireless LAN controller, which would connect your LWAPs all together. When you were just using APs or the WAPs, that they completely did it and connected it back to the router. So the L ones allow you to connect some others together. All right, that's the chapter. Any questions for me? And I managed to click the wrong button on the bottom of my screen, because every time I want to go look at what y'all are putting. So big point on using a VLAN is when you're connecting, you've already subnetted your network in one way physically, and then you want to allow some other different connections on it, and so you can build VLANs to set up virtual local area networks differently than what they're physically set like. So for instance, they're not doing this at the school as far as I know, because it doesn't work like this, but I wish they would. That they've got the student machines on one subnet and they got the instructor machines on another. Well, it would be handy for instructors to also be able to get on student machines, so we could, a way to get around that would be to then do VLANs that have the instructors having the capability to get on the VLAN that would get them onto the student machines. Another one is in the office area of the school. They probably have the office, the business office set up as one physical network, and then student services is another, but you may want to cross those. Another one is that, for instance, student services has offices on each of our 6 campuses, but that you want those people to all be able to contact back and forth with each other, just like they were all sitting there together on the same network. So you can use a VLAN for a lot of different capabilities. Any other questions for me? And the test is chapter 12 next, 11 and 12. And I did have that wrong on the calendar, but I fixed it this morning. So you don't have a test this week, that you'll have a test next week. That will cover 11 and 12. And then I fixed that one this morning after somebody pointed out I goofed on that one. So 11 and 12 is next week, not this week. All right. I don't see any other comments, so I'm going to stop the recording. I'm going to tell y'all all to have a good week, and I will see y'all next Tuesday morning.